Okay, so here when we're doing coordinate geometry, okay, we're trying to write proofs, so not real proofs, they're not like geometric proofs with 2 columns or anything. We're just trying to show that in general, at any given time, these properties of our parallelograms and whatnot happen to be true, okay, regardless. So rather than using specific numbers for specific ones, okay, like a rectangle with a side of 12 and 7, we're going to be doing them in general. So I'm going to teach you how you can do that. Okay, the key here is using some convenient selection of points. You get to pick the points that you're going to use. Okay? Awesome sauce. So let's go on to the first thing it says. Prove that the diagonals of a rectangle are equal. Okay, so notice I already have a grid system set up. Okay, coordinate geometry means we have some type of an x plane and a y plane. Okay, have something on coordinates like you do in Algebra 1. But instead of putting units on there like we have actual graph paper with units and boxes and squares, we're not going to put anything on there because we don't have a set of units. Okay, it's not like we're going to have 1 be this much and 2 be that much and 3 be this much and 4 be that much or whatever. It's going to be some random arbitrary length. Okay, so draw on your paper a nice rectangle. Okay, do the best you can to draw a rectangle. So in a rectangle, all of the angles are 90 degrees. That way we know it's a rectangle. So we need to put some coordinates on here. Now what is the first coordinate that we can see that's pretty obvious? 90 degrees is not a coordinate, but the origin here has a coordinate of 0x and 0y. Okay, the origin. So we get to determine how far to the right have we gone to put a coordinate with this point of our rectangle. Okay, 5 is too specific. Remember, I said no numbers whatsoever. We're going to use letters. So which letter would you like to go to the right? You want to go A units? So whatever we're going to say A units is, okay, A could be 9, A could be 3, A could be 4.8. We have gone A units in the X direction, and how many in the Y? 0. We've gone 0 in the Y because we're on the X axis. We've gone nowhere vertically. So that is a coordinate point A, comma 0. Some distance A, comma 0. Now what about up here, this point? How high, what letter do you want to go in height?
Q.
Q is not a good letter to put. It looks like a 9. What? H for H? Okay, whatever. Q is not, it looks like a 9. Don't use Q's. So if I go H up, what are the coordinates up here? How far have I gone in the X? 0 in the X and H units up. Remember, X goes horizontally, we've gone nothing. O, we've gone 0 to the right and H units up. It is O. That's what it says, OH. So then what are the coordinates of this point out here? A, comma H. Ah, that's right. A, comma H. We've gone A units in the right and H units up. So this has 2 letters and no zeros. Okay, so we're asked to prove that the diagonals of a rectangle are equal. So let's draw in and do this one at a time. Let's do this one first. So here's our diagonal that goes from the origin to the point AH. That is a diagonal. It connects a corner to a corner. So what kind of a lovely triangle do we have right here? A right triangle. So if we want to show that they are equal, we have to find this thing's hypotenuse, basically. So let's call this, let's call it, what letter do you want to call it?
Z.
Z?
Yeah.
Z it is. So So we're going to find z. So whose theorem shall we use with the right triangle in order to find the length of z? Mr. Pythagoras, which says that a squared, the length of the leg, plus h squared equals z squared. Okay, and we want to solve this equation for what letter?
Z.
For z. We want to solve it for z. So can we add a squared and h squared together? No, but they can live next to each other, and that's perfectly okay. So how do I get rid of my square over here? I square root this. Both sides, and that gets rid of the z squared. Does it do anything to that over there? No, it does not. It does not because there's a plus involved. So z is the square root of a squared plus h squared. That is the length of z. Not very satisfying, right? You can't go to the store and buy something with that length. But if you tell me what h and a are, if you give me a letter or a number now, I can plug that in and actually figure out what that length is. But this is the equation that goes along with the length from here to here. So we're going to do a similar thing and find the length of the other diagonal. The other diagonal. What letter should we call that one? Q. Not Q. Q's look like 9s. C is a nice one, aka the hypotenuse of this. So we're going to do the same kind of thing to find the length of this diagonal. So we're going to use our buddy Pythagoras again and write a squared plus h squared equals c squared. So now I'm using this right triangle here to figure out my hypotenuse once again. So how do I solve for c? Square root both sides, and I get the length of c is equal to the square root of a squared plus h squared. Okay, now I check. Is there a difference between these two equations? No, there's not. Okay, and since there's no difference, that means that z and c have to be equal. Because their equations are equal. They have the same letters, they have the same algebra, everything about them is equal. Therefore, the diagonals of a rectangle are equal. Okay?